Today we're going to take everything that we've done so far with prisms, cylinders, pyramids, cones, and spheres, and we're going to put it together. And we're going to do shapes like you can see here in number 1 and number 2. They're called composite shapes. And so we're going to focus on finding the surface area of composite shapes. Now, if you look at these two, you notice that we don't have a formula that tells us how to find number 1, like just straight up, this is what you plug in, this is what you do. But what I do notice is that you should notice that this is a pyramid and this is a cube or a rectangular prism, right? And so we need to pay attention to those things. Now, you're not going to be able to use your lateral area and surface area formulas the way that you always have. Because if you notice, there's this surface that's right in here that won't be included with the pyramid, and it won't be included with the cube, okay? So you're not going to need it, because what you want to think about is what would be the surface what are the surfaces that I'm going to paint? Now, you could do this problem the long way, is what I would consider the long way, in that you can find the area of each of the triangles of the pyramid, you can find the area of each of the squares of the prism and add them all together. So you always have a backup if you don't see what else you're going to do. So when I put these two shapes together, what surfaces are added to the prism by placing the pyramid on top? Well, when you add that pyramid on the top, what you have added to that prism is you've added those 4 triangles, which, if you pay attention, if you notice it, that is the lateral area of your pyramid. Those 4 triangles are the lateral area of your pyramid. What surfaces are you taking away? Well, you're taking away this surface, right? That surface of your cube, that top part. So it's not lateral area and it's not surface area. So what you want to do is you're going to take away one base, right? You're taking away one base. So your total surface area above, you would take the lateral area of your prism, you would add one base of the prism, and you would add the lateral area of the pyramid. Okay, so I like to write it like that so I can think about it. Again, you can find the area of each. You could find the area of the front, and there are 5 of those, the 4 lateral faces and the 1 base. You can find the area of your triangle, and then there are 4 of them, and you can add them all together. You can do it that way, but we want to use our formulas whenever we can. So the lateral area of your prism, that's pH, right? And then we've got the base of our prism, and then we need the lateral area of our pyramid, that's PL over 2. So we've got our perimeter of our base, right? So here is our base. So the perimeter of our base is 8 times 4, that's 32. The height of our shape is 8. The area of our base, the base is a square, so that's 8 times 8, that's 64, plus the perimeter of the base of the pyramid. Now we want to shift up and look at the pyramid. Now it just happens that they line up all together, so it's the same perimeter, so it's still 32. The slant height of the pyramid, that is right here. The slant height of your pyramid is 10, and then it's over 2 because the formula says so. So if you do 32 times 8 plus 64 plus 32 times 10 divided by 2, you can type that all in at the same time, and you'll find out that your total surface area, meaning the area of the surfaces that are visible or paintable, if you want to look at it that way, on this prism with a pyramid on top, is 480 meters squared. Okay, so that's if you put one on top. We've added one on top. Now, in number two, we're taking it away. We're cutting a hole. So we started with a solid prism, right? We started with this solid prism, and we're cutting out a hole that is a pyramid. So what surfaces are added to the prism when you cut that pyramid out of it? Well, we add those 4 triangles. Again, those 4 triangles of the pyramid, that's your lateral area of your pyramid. So we're adding 4 triangles to our situation. And then what surface are you taking away? Well, because we're taking away, we're cutting out. Now we've lost that area on that top face. So we've lost the base of the pyramid. Now notice the pyramid doesn't take up the whole prism. So you're just losing that little piece. So we have to be specific about the base of the pyramid. On number 1, the base was the base of the pyramid and the base of the prism. Okay, so find your total surface area. Now again, you can find the area of each of those individual two-dimensional surfaces, all the rectangles, and then you can add the 4 triangles and then take away that red square from the base of the pyramid. Or think about it this way. You could find the surface area of the entire prism. Okay, so think about what you've got. You've got the entire prism, top, bottom, right, left, front, back, right? We've got the surface area of the entire prism. And then we can take away the base of the pyramid. So then that takes away this red square. But when I drill down into that, then I've got to add the lateral area of the pyramid. So you don't have to do this all in one step like I'm doing. You could do the surface area of the prism. So let's just think about this, the surface area of the prism. Well, that's pH plus 2B. So the perimeter of the prism would be 6, 6, 6, and 6. So that's 24. The height of the prism is 4. And then plus 2 times the area of the base. The base is a square, 6 times 6, so that's 36. So the surface area of the prism, 24 times 4, and 2 times 36. So my prism, that's 168 centimeters squared. That's for the whole prism with no hole. Okay, now I got to take away the square because now there's a hole there. So I've cut that. I don't have to paint that. That's gone. So I need the square. So the base of the pyramid is 4 times 4, so that's 16. So now I'm going to subtract 16. So 168 minus 16, yeah, I'm at 152 right now. But when I drill that in, now I've got 4 surfaces, 4 triangles that I need to get on the inside, right? Well, I need to kind of back up and show you this. When you cut through this, right, you create this right triangle, because to find the lateral area of the pyramid, I need that slant height. So you can go through and do Pythagorean theorem, but for today, I'm just going to tell you that slant height is 6.3. That right triangle right here has a height of 4, and, oh, it's not 6.3. I did it wrong. Sorry. It is, it's 4.5. See, it's easy to make a mistake. It's 4.5. So sorry, I'm fixing my mistakes. So now I need the lateral area of the pyramid. So lateral area of the pyramid, I just used Pythagorean theorem to find that 4.5. And what I originally did is I used the wrong height. I was thinking it was a cube like the first one, but it's not. Its height is 4. So it has a height of 4, and it has a rate or an apothem of 2 right there. Okay, so I gave you the slant height, so you don't have to worry about that though. So you need the perimeter of the base. It's the perimeter of the pyramid base. So that would be 4, 4, 4, and 4. So that would be 16 times the slant height, which is 4.5, over 2, because that's what the formula says to do. So 16 times 4.5 divided by 2 is 36. And so then I had the 152. I need to add back in those 3 triangles. So 152 plus 36 is 188. Okay, so you get 188. And that would be centimeters squared. Okay, so that is the total surface area that you would paint if you were doing this composite. So let's look. So you just kind of have to start looking to see, and you have to decide how much of the areas do I need? Do I need both of the bases? So you kind of want to start with your lateral area and decide, can I use that? So let's look at this. So what we've got is we have a cylinder with a sphere, half of a sphere on one side. And so we have a hole. This is a hole right here. So think about what you need. You need your lateral area because you need this surface. So you need your wrapper, right? So you need your lateral area of your cylinder. You need one base of your cylinder because you have that whole circle. So you need to add one circle. So plus one circle. And then you need to subtract half of your sphere. Okay, because it's half a sphere and it's, not subtract, you would add half the sphere because you're adding that surface. This is all paintable surface. It's like a bowl on the inside of that, okay? So you're adding that half a sphere. So let's do our lateral area of our cylinder is 2 pi r, the radius is 3, times the height of the cylinder, which is 9, plus the circle on the bottom, plus, if you go ahead and simplify that, then it'll be 2, and it's r squared, sorry, plus pi, plus 2 pi r squared. So if you just do it, if you leave it in terms of pi, then you get 54 pi plus 9 pi plus 18 pi, which is 81 pi, or 254.5 inches squared. So just keep thinking about what surfaces would I paint. So in number 4, you have a cone and you have half of a sphere. Now we're not painting this circle because it's shared by both. It's hidden. You can't get to it. If I glue those together, then I don't need to paint that. So we don't need our circle. So we just need the sides of our cone. So we need the lateral area of our cone. And then we need to add half of the area of your sphere, okay? So the lateral area of your cone, that's pi RL, and then half of the area of your sphere, okay? Now, if you look, though, we ran into a problem already. I've got pi, I've got R, I need L. Well, remember with that cross section, we've created this right triangle. We can do Pythagorean theorem. And it gets to be like 18.02 or something, so we'll just use 18 because to the nearest tenth is 18.0. So now we have our slant height. That's just using Pythagorean theorem. So times 18 plus, again, this half of 4 is 2 pi. You don't have to deal with that. You can just type this all in on your calculator, all just like it is. And then the radius squared. So if you do 6 times 18 plus 2 times 36, you get 180 pi, which is 565.5 feet squared. Okay, so you really have to think about pulling these shapes apart. You've got a cone, you've got a sphere, it's half a sphere. Okay, you really have to think about what pieces do you need and how do you add them together, particularly like this one. If you look at number 5, this one's tricky. So basically here, think about how you would construct this. You would start with your whole big cylinder, right, which has a radius of 9 and a height of 5. And then you've got your small cylinder on the inside. It has a height of 5 and a radius of 7. So what we want to do is, if you think about it, okay, I'm going to take the whole thing. So I would paint all of those outside surfaces. So I need the surface area of that outside cylinder. Well, then I also need, I need the lateral area because this is the hole, right? So I don't need that and I don't need that circle. So I don't need the surface area of the small one. I need the lateral area of the small one. So I need the surface area of the large. I need the lateral area of the small. Okay, but remember that when we did the surface area, we did include this whole circle and this whole circle, right? And so what I have to do is then I have to take it away. I have to take away those circles so that all I have is this leftover piece, right? Because what we're doing, if you look at it from the top, is we just want the area of this. Now, this again, this is not the only way to think of this. You can do the lateral area of the big one and the lateral area of the small one. And then you can just take the big circle and subtract the small circle for the top and the bottom. You can do that too. That is totally fine. It's all kind of what you see. So I just took care of the circles all at once by doing the surface area. So your surface area, you would have 2 times pi times the radius of your big one times the height of your big one plus 2 times pi times the radius of the big one, okay? 2 pi r squared. And then your lateral area would be 2 times pi times the radius of your small one times the height of your small one. That would be your lateral area. And then you need to take away your circles. You need to take away those small circles that are 7. So I have 2 of them, so I need to take away 2 pi r squared. When you go through all of that, you have so you have 90 pi and then 162 pi. And then you add 70 pi because you're adding those surfaces in there. And then you're subtracting 98 pi. So 90 pi plus 162 pi plus 70 pi minus 98 pi, you get 224 pi. And you can convert that to a decimal version. Okay, now 6 is really kind of up to you, particularly when you have the shapes where you have rectangles and triangles. You could say, okay, the area of the front and the back. So you could do front plus back plus right plus left plus bottom plus the part of the top, right? The top. That would give you all of this, and the back piece and the bottom piece. So you would have all of that to paint. And then you would have your 4 triangles. So you can do it that way. There's several, there's so many different ways you can do it. You could also do the lateral area of the prism. So you could do, let me erase all of this so you can see it. So you could do the lateral area, which would be all the way around. Okay, the front, the right, the back. You could find the lateral area of the prism. You could add the base of the prism. That would give you this piece right here. And then, or you could add 2 bases, and then you can subtract. So you can also subtract the base of the pyramid, or then you can add the part of the base, right? You can add the top. So it really just depends on what you see and how you see it. What I did is I found the surface area of the prism, the whole thing, everything, and then I subtracted the base of the pyramid. So I subtracted, so I found everything, all of the surfaces of the prism. Then I subtracted the base of the pyramid because that much isn't getting painted. And then I added the lateral area of the pyramid. I think that's easier to keep up with as far as like not having a bunch of different options of things to look at. But you can always fall back on just going back to your regular rectangles and adding them all up. It's just more to keep up with. Okay, so when you go through this, your surface area of your prism, that's pH plus both of your bases. So here's the base of your prism. And then you have your base of your pyramid. You can see if this is 7, this is 5, then this is 5. So your base of your pyramid is 25. And then your lateral area of your pyramid, that's PL over 2. You have your slant height is also 5. your perimeter is 20. And so you can go through and do the math and get that. That is 281. So you have a lot of options there, but really it just comes down to you're adding a bunch of rectangles and triangles together. So that may be the easiest way for you to see it. But you can choose, particularly when you have prisms and pyramids, how you want to do the problem.